right, hello, welcome to lab. Today we're going to be talking about using nonlinear models. So this is going to build a little bit on what we did in our last in-person class that we had. So if you can recall from a couple weeks ago, we talked about a couple different ways that you can have nonlinear models. And so one of them was polynomials. That's like lab 3 that we did, where you had different polynomial terms that you were fitting with the horsepower, trying to predict miles per gallon using that auto data. And then we also talked a little bit about step functions, linear splines, cubic splines, and natural splines. And so for this lab, we're just going to be focusing on this last one. We basically were building up to the best scenario natural splines. And so that's what we're going to be talking about today. So here's just a picture from our nonlinear models class from a couple weeks ago, just to sort of remind you about what we were talking about when we were talking about these different types of splines. So you could have these piecewise splines, which were not ideal because they had this kind of cut point. You could kind of try to smooth over that by having a continuous piecewise spline. A cubic spline was even better because it was able to kind of smooth even a little better right at that inflection point or at the knot. A linear spline basically just fits a line at either side instead of a cubic function. And then finally, natural splines are splines that extrapolate linearly beyond the bound knots. So they're cubic within the bound knots and then linear on the edges, which is good because it basically adds some extra constraints to let us put more internal knots for the same degrees of freedom as a regular cubic spline. So that's just a quick refresher on what's going on here. And it turns out this is really easy to do with the tools we've learned so far in R. So you can actually transform any continuous or numeric variable into a natural spline by using the step_ns function in a recipe, like the recipes we've learned so far. So in the lab that we just were working on previously, you were scaling your variables using step_scale. And so kind of using that same process, you can turn a variable into a natural spline using the step_ns. And then you can specify the degrees of freedom that you want to use for that variable using the degree or DEG_free parameter. And so it looks like this. So here I'm using that same auto data. I've loaded the library, the ISLR library, so I can pull that auto data set. In my recipe, I'm fitting miles per gallon. I'm trying to predict miles per gallon using horsepower, but I want horsepower to be fit using a natural spline. So I use this step_ns function to indicate that I want to use a natural spline. And then here I can set the degrees of freedom using the deg_free. So how many degrees of freedom do you think I allocated to the horsepower variable? I feel like we're doing some Dora the Explorer. I'll pause a second. You can say what you think the answer is either out loud or in your head. It's 2, right? Because here I've got degree of freedom equals 2. And so this is going to be, if I were to plug this then into a fit function, I'd be fitting a model that was predicting miles per gallon using horsepower, but we're fitting horsepower flexibly using a natural spline with 2 degrees of freedom. And so instead of actually specifying that degree of freedom using that parameter, you could use the tune function to tune this. And so this is going to be kind of like lab 4 where we were tuning based on penalties. Now you could tune based on the degrees of freedom that you want to allocate to a certain variable. And so for example here, instead of putting 2 under degrees of freedom, I can just use that tune function as a placeholder. And then I can use something like tune_grid to be able to choose the best degrees of freedom for this given model. So this is what you're going to be doing in this lab. Today's lab is pretty short. It is a lot shorter, I think, than the other labs because I've basically designed it for you to be able to work on and hopefully complete just today during the class time. So you can have it turned in by Thursday at midnight. And that'll hopefully give you a little bit of extra time to study for the midterm exam that's coming up. So go ahead to our website, find Lab 5, pull your starter files from GitHub into our studio, and note again that the due date here, I've intentionally made this lab short so it can be completed by Thursday at midnight. So let's do that together. I'm gonna switch to our website. So I'm going to sta363s20.lucymcgowan.com. And again, just so as a reminder, if you need any help through this, I've put in here this chat on Gitter. This is a great place where you can go to ask me questions. I'm going to be available during our class times as well as during normal office hours here, so you can kind of live chat if you have specific questions. And also remember, Sarah's hosting study sessions still on Monday nights, and so I hope you'll take advantage of that next week before our midterm. Okay, so if we go to our syllabus, we'll scroll down to today's date. And so today, Tuesday, March 24th, under Nonlinear Models here, Lab 5. Here's our lab. So here we go, here it is. We're gonna be using 3 packages, Tidyverse, Tidymodels, and ISLR. Go ahead and pull your project in from GitHub. We just have 4 exercises. This should be super quick, hopefully. The first is just kind of looking at that wage data set that we're going to be using. And so we're using the wage data set from the ISLR package. So just describe the variables and how many observations they are. And then go ahead and create a model specification, setting the engine to LM. And then we're going to make a recipe where you're using the step_ns function along with the tune function to be able to tune it. And we're going to be using that natural spline for the age variable. And then finally, you're going to use tune grid to be able to pick the best degrees of freedom that we should be using for that variable. All right, good luck. I'll see you in a couple days.